In this video, we're still having a look at the adding and subtracting of algebraic fractions. In video 12, we learned that when you want to add or subtract fractions, you need to get the common denominator. But in our example, one of the denominators can first be factorized a bit further. So that is exactly where we'll start so that we can ensure that both denominators are broken up into factors. So, in our first term, the denominator has a common factor, so I'm going to start off by taking out x as a common factor and I'll be left with x plus 4. And this means that this denominator now consists of two factors, x times x plus 4. The second term's denominator is already one term and consists of the factors 4 times x. Now we can determine the common denominator. The common denominator should consist of all the factors of both denominators. I'm going to start off with the constant part, and here we have 4, which means 4 will be part of our common denominator. Next, both these denominators have the factor x, and that means x will be part of our common denominator or our lowest common multiple. Lastly, there's still a factor x plus 4 in the one denominator, which means it has to form part of our common denominator because every factor should be in our common denominator. Next, we need to determine the equivalent fraction for each of our original fractions with this new common denominator. For the first fraction, the denominator was multiplied by an extra 4, which should then be repeated in the numerator. And here it's important to remember the whole numerator should now be multiplied by 4. And here we now have our new numerator. In the second fraction, the denominator was multiplied by an extra bracket of x plus 4, and this should now be repeated in the numerator. This means that the numerator of 2x plus 1 should now be multiplied by x plus 4. And here it is important to now realize that the minus in front of this fraction will now also be multiplied into the numerator. Next, we need to simplify our numerator. So I'm going to start off by multiplying 4 into the first bracket, and in the second term, we will multiply the two brackets with each other. Lastly, we can multiply the minus into the bracket, and the final step will then be to add up all our like terms to get our final answer. Example 2. Simplify. Here we need to subtract two fractions, and for that we need to start off determining whether the denominators have already been broken up into factors. The denominator of the first term is a trinomial that can be factorized further. And if you have a look at the denominator of the second term, the 4 minus x is very similar to one of the factors of our first fraction. So we can manipulate this by writing x minus 4. But if we do this, it means we've changed the sign of both the x and the minus 4 by taking out a minus as a common factor, which means the sign in front of the fraction should change. So here, our common denominator consists of the factor x minus 4 and x plus 1. The first term already had exactly this as a denominator, so it stays a numerator of 3. The second term's numerator should now still be multiplied by another x plus 1 to form the equivalent fraction with this given denominator. Next, we need to multiply out these brackets and then lastly add up all the like terms. In example 3, we also need to simplify, and we'll once again start by factorizing the denominators. The first term's denominator is a trinomial that can be factorized in x minus 3 multiplied by x minus 2. Our second fraction has already been factorized in the denominator into the factors x minus 3 times x minus 3. To determine our common denominator, you should realize that x minus 3 is now in both denominators and the highest exponent is 2. Reminder that we always take the highest exponent of any factor because we can't make any denominator smaller than it was. Then we also need to multiply with the factor x minus 2. Now we need to get the equivalent fractions for each of the original ones with the new denominator. So for our first fraction, the numerator of 3x minus 1 should still be multiplied by the factor x minus 3 because the denominator was multiplied with an extra factor of x minus 3. And our second term's numerator of x should still be multiplied by x minus 2. If you prefer to always go and calculate these equivalent fractions in a separate calculation, you can always continue doing that. Lastly, we need to multiply out the brackets and then add up all our like terms.